Hey everyone, and welcome. Today, we're gonna jump right into the amazing world of 3D printing. You know, that incredible tech that literally lets us turn our wildest digital ideas into actual physical things. So let's start with a really basic question. How do you take something that's just an idea and actually hold it in your hand? I mean, think about it. You could design a super unique phone case, or that one little plastic part you need for your dishwasher that broke, or even a piece of art, and then poof, a few hours later, it's sitting right there on your desk. I mean, how does that even work?
Well, the answer, of course, is 3D printing. But here's the thing that most people don't realize. It's not just one single magical technology. 3D printing is actually more like a whole toolbox, you know? It's packed with all these different tools for totally different jobs, and each one builds stuff from the ground up in its own unique way.
And to make sense of this whole toolbox, we can basically sort everything into three big families. First up, you got the printers that build things with melted filaments. Think of it like drawing. Then, you've got the ones that use light to cure liquid stuff. And finally, you have these industrial beasts that fuse powders together. So, let's dive into each of these worlds.
All right, first up is extrusion. Now, if you've seen a 3D printer out in the real world, like at a school or a library, chances are it was one of these. The absolute best way to picture it, just imagine a hot glue gun, but a really, really smart one. Like one that went to MIT and got a degree in robotics. Okay, so the fancy technical name for this is fused deposition modeling, or just FDM for short. And this is by far the most popular kind of 3D printing on the entire planet. And the reason why is super simple. It's cheap. I mean, you can get a machine that makes absolutely incredible stuff for less than you'd pay for a new video game console. It's wild.
So, how does this whole robotic hot glue gun thing actually work? It's honestly pretty straightforward. The printer takes this long spool of plastic filament, heats it up until it's molten, and then it just draws out the very first layer of your object. Then, the print head moves up just a tiny fraction of a millimeter and draws the next layer right on top. And it just keeps doing that, layer after layer after layer, until your thing is finished.
And look, don't let the plastic filament thing fool you into thinking this is just for making little trinkets or toys. No way. This exact same idea is being scaled up, way up. They're printing with concrete now, building entire houses, layer by layer. Yep, we are literally printing homes. Okay, so if printing a house wasn't mind-blowing enough for you, how about this? What if we could print with life? This is called bioprinting. Instead of using plastic, scientists are using these special gels that are loaded with living cells. And the goal here? It's absolutely incredible. They want to be able to print custom-made tissues and maybe one day, entire organs for people who need transplants. This isn't science fiction anymore. The future of medicine is literally being printed as we speak.
Okay, so let's leave the world of melted plastic behind for a minute and step into a totally different realm, the world of liquid and light. This next family of 3D printing is all about one thing, getting absolutely breathtaking, insane levels of detail. And it does it by using light to basically sculpt things out of a liquid resin.
So, when it comes to sculpting with light, there are really two main approaches. The first one is called SLA, and you can think of it like drawing with a super fine laser pointer. It carefully traces out every single detail of a layer. The other method is called DLP or LCD, and it's completely different. It's more like using a digital projector to flash the entire layer all at once. As you can probably guess, this makes it way, way faster. It's kind of like the difference between drawing a picture line by line versus just taking a photograph of it.
And you know what's really wild? You can actually thank your smartphone for all of this. Seriously, those super high-resolution LCD screens that make photos on your phone look so crisp and amazing, well, companies figured out how to use them in 3D printers. And because of that, the cost has just plummeted. You can get a printer that produces professional-level detail for like under $400. It's incredible.
But wait, just when you think it can't possibly get any cooler than that, there's something called volumetric printing. Okay, this stuff is next level. It basically takes the entire rulebook of printing layer by layer and just throws it out the window. It creates the entire object all at once by projecting light into this spinning vial of resin. It is straight out of science fiction. It's probably the closest thing we have right now to a real-life Star Trek replicator.
All right, from the world of light, we're now moving into our final category, the world of powder. These are the real industrial heavyweights of 3D printing. We're talking about machines that create unbelievably strong and complex parts out of stuff like super durable nylon and even metals like titanium. Now, one of the coolest things about this powder-based printing is that it solves a massive headache that plagues other types of printing. You see, with most printers, if you have a part that hangs out in midair, you have to print a bunch of temporary scaffolding to hold it up, which you just break off and throw away later. It's a pain. But with these systems, that problem just goes away. The bed of unfused powder around the object acts as a natural support structure. This means you can create these crazy, complex geometric shapes that would be literally impossible to make any other way.
And the process itself is just awesome to watch. It's like something out of a movie. First, a little roller comes across and spreads this super thin, perfect layer of powder. Then, a high-powered laser zaps across the surface, instantly fusing the powder particles together exactly where your part needs to be. Then, the whole build platform drops down a tiny bit, the roller adds a new layer of powder, and the laser does its dance all over again. It repeats this over and over until your part is finished, completely buried inside this solid block of powder.
And again, we are not talking about plastic doodads here. We're talking about printing actual, functional jet engine components out of titanium, custom-made medical implants from stainless steel that go inside people's bodies, high-performance parts for race cars made from aluminum. This is truly industrial-strength 3D printing.
But using a laser isn't the only way to work with powder. There's another really cool technology called jet fusion. The best way to think about this is like your 2D inkjet printer at home, but on a massive 3D scale. Instead of spraying ink on paper, it sprays a special binding agent onto the powder, essentially gluing the particles together, one layer at a time.
What's so revolutionary about this is something called voxel control. Now, what's a voxel? Simple. It's just a 3D pixel. It's the tiniest little building block of your 3D object. And this technology lets you control the color and even the material properties of every single individual voxel. That gives you a level of creative control that is, well, it's just mind-boggling.
Phew. Okay, so we've taken a quick tour through 3 pretty different worlds, right? We've seen melted plastic, we've seen sculpted light, we've seen fused powder. We've talked about everything from smart hot glue guns to Star Trek replicators. So now, let's just pull back for a second and put it all together to see where each one really shines. So, when you boil it all down, it looks something like this. Extrusion, that's your all-arounder, the people's champion. Its superpower is accessibility and just how versatile it is, for everyone from a hobbyist in their garage to people building actual houses. Then you have resin. That's the artist of the group. Its superpower is that incredible, insane detail and speed, perfect for things like jewelry or dental models. And finally, you've got powder. That's the industrial powerhouse. Its superpowers are pure strength and the freedom to create almost any shape you can imagine, which is why it's used for things like aerospace parts.
So as you can see, we can print with plastic, with metal, even with living human cells. It really just leaves you with one big question, doesn't it? What will we print next?